Okay, array is an important concept uh, uh, in computer science, and array is a data structure that is most often used to build a complex or composite data structure like stacks and queues. Uh, and in this lesson, we will ask about the arrays, and we will see like using some programming constructions, what all different operations we can perform using array, and how arrays are stored in the computer's memory. We define an array as a like collection or a systematic arrangement of the objects of the same data type. And a typically defined definition or a declaration of an array would look something like this. Uh, so an array definition will have a data type. In this case, we have an array of integers, and then we will have the variable name, and we will also see the size of the array. Now, where does the concept of the array fit in programming? Let's say in a program we wanted to uh, like store the marks of 50 students in a class in let's say mathematics, now in our program to store these values, we can declare 50 different integer variables like s1, s2, s3, and so on. Okay, all the way till s50. So we can declare 50 variables names corresponding to these 50 students. Now let's say we wanted to calculate the average marks of all the students. So to calculate that, we will have something like a total of all the marks. So we will have a variable total. This total will be equals to s1 plus s2 plus s3, so on, and all the way till s50. And arrange average would be totally divided by 50. But what if we had 500 students or even more? It would be very unmanageable to declare 500 variables and using them in our statements. So in this case, we declare an array. So let's say we declare an array with size 50, and this array is run of integers. Now in this case also I have 50 different variables, and I access them uh, as S0, S1, S of 1, S of 2, uh, right. We start at the index 0 and we go all the way till index 50, like in fact 49. And our program will be something like we again have variable total, and this time we run a loop from 0 to 49, and we used this variable I as index and keep on adding s of I to total. Finally we calculate average as before, uh, which is total up to 50. Okay, this way an array of integers, we can also have an array of float, an array of characters, or an array of user defined class. Okay, right, or structure even. And this was a simple one-dimensional array. uh, we can also have the array of the two-dimensional or three-dimensional. uh, so let us now see how arrays are stored in computer's memory. So, okay, let's say this figure in the left here is computer's memory, which is divided into these segments or partitions, and each segment is 1 byte of memory. In fact, we are only showing a part of the memory in the form of these segments or partitions, and that's way it is extending towards the bottom and the top, because in reality the memory will have many more bytes. In fact, computer's memory is very large array of bytes. Now, in computer's architecture, each byte of memory has an address. Let us assume that here bottom most byte, which will be somewhere deep down here, has address 0. And as we go on towards the top, we go to increase the index 1, 2, and so on. Uh, Okay, so let's say, for example, if this particular byte has an address 100, then this particular byte will have the address 101, and we will go on like 102, 103, and so on. And as we know, in C and C++, we have pointer variables that can store the address of another variable of similar data. Now, when we define an array, something like an integer, for example, size is 4, then if an integer typically takes 4 bytes of the memory, then an array of 4 integers will take uh, 16 bytes of memory. Okay, when the program executes the execute in the computer, 16 continuous bytes in memory for this array A. So the computer like a continuous block of 4 bytes each, 4 contiguous blocks of 4 bytes each. The first block or the first 4 bytes will be corresponding to A of 0, and the next 4 bytes or the next block will be corresponds to A of 1, and similarly we will have A of 2, A of 3 as well. Okay. Uh, Now, access to an element in the array or its modification, all of these amount will be take some constant time, and it is not a function of the size, or we can say that the time complexity or accessing or modifying an element in the array is O of 1, that is big O of 1. Now, how does this really happen? So let's try to understand. When we declare an array like, say, for example, here we have declared an integer array of the size 4. Then this variable a is nothing but a pointer to the first element in the array. Okay, and we can also say that variable a is the pointer that points to the base address of the array, and this is better explained in a real program. So let's go to a compiler and write some code. Okay, so I will write a simple C program here. What I will do is I will declare an array A of size 4, okay, an integer array, and as I told you earlier, a is nothing but a pointer for the first element in the array. So if we tried to print a, I have written a simple printf statement, which is statement to print the variable of on the console. Then this should give me the base address or the address of the first element in the array. Now run this program and we'll get an output which is equals to 29472. Okay, and this should be the address of the first element, but how do we know that this is the address of the first element? We can print the values of this particular address, and as we know, to print the values uh, at an address of the pointer variable points to, we need to put a star in front of the pointer value in the C or C++. So star A should give us the value at the base address. So the value of the first element in the array. So star A is the same as A of 0, remember. Okay, right, and let us now see what we get. Okay, so the we got an address in the first line, and this address is different from the previous address because every time the program runs a fresh, it will be refreshing the memory allocation will be beginning, and the value that we are getting storing is different, and this is happening because we have not yet initialized or filled any data in the array. So what I will do here is I will fill some data. Let's say a of 0 equals to 1, and a of 1 equals to 3, a of 2 equals to 4, and a of 3 is 5. Okay, and now if we run this again, the first line once again gives us the address of the first element, and the second line gives us the value of the first element, and that's correct. Now I do something here. I will print a plus 1, and if we know the base of the pointer arithmetics, uh, then because a is a pointer to an integer, then a plus 1 should increment the address by 4 bytes, which is the size of the integer, and takes us to the next integer. So a plus 1 should give us address of the second element in the array, and whether the second address is correct or not is something that we can verify by looking at the value at this particular address. So and if I am let's do like the star a plus, okay, a1 or the second one. Okay, let us now run this. Okay, so let's see this one. First line is the address of the first element, and the second and you can see the second address, which is the address of the second element. Okay, is 4 more than that has of the first one, and we have got the value right. Okay, a of 0 is 1 and a of 1 is 3. So now it should be evident why accessing or modifying an element in the array takes a constant time. When we try to access an element in the array's computer first calculate its address and to this particular element using the base address and offset. So for example, if we wanted to take this one element in the array, which is a of 3, then the address is calculated from the base address by adding the offset 3. And the value of this particular location will give us a of 3. All these pointer arithmetics that we are doing here are possibly only to C or C++. And if you are using the language like a Java or any other scripting language, then this would be not working. But still, the internal working of how things happen in memory will be pretty similar. So this was something of the basic about the array. Okay, array and the memory, they are interpreted in a computer program. Okay, okay, fine. So this is the end of the session. Thank you for watching.